Good. Good morning, good afternoon, good evening, everyone. My name is Maria. I'll be moderating today's session, and probably you were expecting to see Kasper here since he was on the promotional landing page. But Kasper was like, I already did too many webinars with you guys this month, so he got Will to do the webinar today. We're going to talk about enabling pull requests in ephemeral environments at enterprise scale. But before we get started, a few housekeeping notes. So this webinar will be recorded. We'll send over webinar replay and presentation slides to everyone who registered for the webinar. We'll have a 30-minute presentation and then 15 minutes Q&A. And you can ask questions in 3 different ways. You can put them in the chat, you can put them in the Q&A section, the best way, by the way, you already know it, or a platform engineering Slack channel. And by the way, this webinar is a part of our platform engineering webinar series. If you're still not a part of the platform engineering Slack channel, join in. You can, I just sent over the link to everyone in the chat. Just join Slack and you will find all the other platform practitioners, and you can DM Will after this session if you have any other questions. That's it from my side. Will, welcome, over to you.
Alrighty, hello everyone. Let me just share my screen and we'll get going. Okay, so welcome to this webinar on enabling PR and ephemeral environments at enterprise scale. I'm William Overton. I'm a senior platform architect here at Humanitec. And yes, as you just heard, you're absolutely welcome to DM me on the platform engineering Slack. I love talking to people. If you have any questions, there's a good place. So you'll be glad to know the slides are really short today. We're going to be spending most of our time looking at a demo. So don't worry if you are already seen too many slides today. Well, this will be quite easy. So the agenda, we're going to look at why ephemeral environments, what is the value of them? Why would you want to go through the effort of setting these up? Then I'm going to quick look at the platform we have set up today, so you can get an idea for the technologies we're using. I'm going to spend some time on dynamic config management and how this all works together. And then we're going to do the fun part, which is the live demo. Alrighty, so why ephemeral environments? So ephemeral environments are a term we're using to mean starting fresh, new environments up on the fly. The moment a developer requests, hey, I want to deploy something, but I want to test this feature branch, right? We want developers to be able to get a fresh, new environment for that as quickly as possible. And the reason they're ephemeral is because they get destroyed when they're done. These aren't permanent environments we're going to keep around for a long time. They're just something we do really quickly for testing, and then we get rid of them. So with that, the ability for developers to create new environments like this allows them to be way faster and way more efficient in their development process. If they have a change they want to try out, just create a new branch. Create a new branch, it automatically gets deployed into a fresh new environment for that branch. And they can test it out and they can work and they can update things without having to get stuck behind, tickets of, hey, can you create me a new environment? Can you create me a database for this test? Really freeing up time from them and also the platform engineering team. The second part, which is on a similar vein, is the reduced disruption and downtime. Because this comes in 2 main parts. If your developers are sharing one development environment, when you scale that up, I'm sure a lot of the people in this call have seen that it breaks, right? Someone merges something into dev, it bursts into flames, something doesn't work, and now people can't keep working. I can't test my change because someone else has broke dev, and that's not where we want to be. And we also get reduced disruption and downtime in the later stages as well, in the QA environments in production, because developers are able to test things in their own branches, knowing it might cause problems. You don't want to test something if you might break the shared dev, But if it's only going to break your pull request environment, who cares? Test it, prove it's resilient. And on that final part is the improved code quality and collaboration. So when I have a change, currently maybe I can get a colleague to review my pull request, to look at the code and make sure, yeah, that looks like it will work, right? But if I can create a new environment for someone to test it out as part of the pull request, they can review the code, they can click a link to browse it and actually test the app. It makes the collaboration and the code quality way better because we're able to catch things. Alrighty. So the setup we're using today is the AWS reference architecture made by McKinsey. And I was going to go through this really quickly, but this is a reference architecture for a enterprise-grade IDP in a cloud-native environment. And obviously this one is focused on AWS, but everything I'm going to be talking about today is not AWS focused. It works the same in any of the clouds. So at the top level here, we have the developer control plane. And this is where we're going to be spending most of our time today. So the developer control plane is kind of in the name. It's how is the developer controlling things and how are they working on their day-to-day? So the main parts we're going to be seeing today is we're going to be using GitHub as the developer's sort of main entrance into the platform. We're going to be using Score, which is a workload specification, which is how a developer describes how their workload needs to work. And when I say workload, you can think microservice if you've not heard that term before. And we'll also maybe touch on Terraform, but that's more on the platform engineering side. Okay. And then in the integration and delivery plane, we're going to be using a lot of GitHub actions. We're going to be running through those. And then we also have every step of the way that our application needs to get deployed. So we have Amazon's ECR for storing Docker images in. We have the platform orchestrator, which I'm about to talk more about. And then we have the Humanitec deploy mechanism, which is what we're using for our CD, but you could use something like Argo or Flux or any other tool. And I'm going to move on from here because the rest of the resource plane isn't too important for this. Alrighty. So to create dynamic environments, we need to be able to create the application config and the environment config dynamically, because we can't have it static because we want developers to be able to self-serve it really easily. So the way this works is developers are going to be working in Score, the workload specification I just mentioned. I'll show you more of this later, but the developer is going to take their Score file, commit it into their source code management, and that's going to trigger CI. CI is going to inform Humanitec platform orchestrator, and then the orchestrator is going to read that Score file. It's going to combine it with context. So that might be, hey, the environment type is staging. And then it's going to use the configurations made by platform engineers, which we'll touch on more in a second, to actually go ahead and create and deploy that environment. Okay. So now we're going to sort of look at this again for two different use cases that a developer might run through. This is very much from the developer side. We've got plenty of the webinars about the platform engineering side. This is what the developer is going to get. So this is deploying to dev. And this is a golden path. And by that, we mean it's something that is standard. It's very easy for the developers to do. And it's something that is understood and sort of universal. So they have their Score file. They run a deployment. And in this case, the context is the environment is development. So that's going to hit the platform orchestrator, which is going to take, which is going to do this process we call the read, match, create, deploy. And what this is the steps that the orchestrator follows to be able to ensure that an environment is ready to be that the deploy can be done into. So for development, what's going to happen when we go through this read, match, create, deploy process is we're going to find that EKS clusters already exist because development already exists, right? We already have a development environment. So it's going to configure the cluster. It's going to inject RDS credentials because in this case, you see our workload is using Postgres. In our reference architecture, we're using RDS. So it's going to inject credentials from RDS. It's going to inject the S3 bucket credentials. And it's going to configure DNS updates as well, which might not need to change, right? Because development environment already exists. So this is sort of showing how the platform orchestrator can deploy and keep updated environments that already exist, like development. So the next step after that is the golden path for creating new environments. And this is where we're going to be focusing more on in the demo. So the developer has their score file, exactly the same. But this time when that deployment's being done, maybe by our CI system, the context this time is different. The environment is set to ephemeral. And this could be, environment set to feature branch or pull request. In this case, we're using ephemeral. And this is going to be very different because this is telling the platform orchestrator, I want a new environment that doesn't exist. But from the developer's point of view, this all works exactly the same. They don't have to know the difference between deploying to development and this new environment, and neither do the platform engineers. Because the orchestrator is going to get this request, it's going to get that score file, that workload, it's going to get the context, and it's going to run through the same read, match, create, deploy process. But because this is a new environment, the outcome of that can be very different. So in this case, we're going to create a new namespace for our deployment. We're going to create a new RDS instance. Because remember, our score file is saying to use Postgres, we're using RDS in our setup, but we obviously don't have a database yet because this is a completely new environment. So we're going to get a new RDS instance, which is created by the platform orchestrator. We're going to get a new S3 bucket, and we're going to create a new DNS entry. Alrighty, so with all that, I promise the slides will be short. We're going to jump into a demo. Okay, so to demonstrate this today, I'm going to be using this ephemeral environment demo, and we'll share a link to this after the fact, after the webinar, because it's actually a public repository. So this Git repo is made to basically be an application repo. So somewhere a developer might be developing a service and using Score to handle their deployment. And then what we're going to look at is the fact that we have GitHub Actions set up to work with the Humanitec API to create these ephemeral environments for developers to test on with pull requests. So with that, I'm going to swap over to my text editor because I'm a developer. So here I have the ephemeral env demo, it's that same Git repo, and I can open up the score file. And I've talked about score quite a bit already. So what I want to do is really quickly run through this to sort of show how the score format works. And if you're interested, I really recommend you look at the score specification afterwards. So the first thing we have is the metadata. So this is the name of the workload. In this case, it's hello world. It's very imaginative. Then we have the service section. And this is where we define basically how this workload is going to be accessible. So in this case, I want to expose my service on port 80, but my container is going to listen on port 3000. Then we have the container section where I have a container called front end. I have the image that I want to deploy. In the real world, this would be something that would be set by your CI system. So you commit code, runs a build, creates that new image, and then you would put that image name here as part of your CI build. Then we have the variable section, which is where we define all the environment variables that are going to be sent to the container. So it's really important here to remember that the score file is the same in every environment. So you wouldn't, for example, put env equals production here, because then you'd set every environment to production, and that wouldn't make sense. That's something that is handled by the context of the orchestrator. The score file is simply to say, hey, this is what my application needs generally to run. So we can do things like have a message, have a port number that's the same in every environment. But when it gets to database credentials, which this application requires, obviously this gets very different. So to handle things like database passwords, database usernames, which are going to be created automatically by that read, match, create, deploy process, we use references to the resources section. So the resources section is the one single place where a developer lists the infrastructure that app needs to work. So I'm saying here in an abstract way, hey, for my app to work, I'm going to need DNS and I'm going to need Postgres. But it's really important here that you notice that I'm not saying use Postgres RDS in the EU West 1 region with 10 gigs of memory. Yeah, I'm not giving any of this information because we're abstracting that cognitive load away from the developers and making it simple, right? When I say I want Postgres here or I need DNS, what I'm doing is I'm asking for the golden path. Okay? Hey, give me the standard Postgres, give me the standard DNS that I know will work. And that's we find when you offer this to developers, they want to use because it's easy and they don't have to worry about a lot of extra details that, cognitive load. Alrighty. So with this and with our Git repo here, what I'm going to do is I'm going to make a change to simulate a developer making a change. I'm going to open a pull request. So for example, instead of hello team, it's going to be hello world, for example. And let's also add new infrastructure, for example. So let's say for this new feature I'm developing, I want to serve images, okay? So I'm going to create a new asset, so a new resource, and I'm just going to call it images. This is just a name that makes sense to me. I'm going to set the type to S3 because I want an S3 bucket. And then I'm going to list the properties that I want to be able to access. So I want to know the name of the bucket. I want to know the region the bucket's deployed to, because that's information as a developer I need to know. So I'm going to come over to my variables section and GitHub Copilot's going to write my score file for me. So I'm going to have the images bucket. I'm going to have the images region. And these are going to be environment variables that are passed to my application. But the value is going to come via references to this resources section, which is created and maintained by the platform orchestrator. So with this, I'm going to make a change the same way a developer would. I'm going to create a new branch, my test. I'm going to add my file. I made a really cool change. And then I'm going to do a git push, setting my upstream at the same time. And then now I've made this new branch, I'm going to create a pull request. So if I come into here, I'm going to have my pull request of I made a really cool change. Can't wait to test it. I'm going to create this pull request. And what's going to happen now is the GitHub actions that I have set up in this repo are going to trigger. So you see this is happening here. I have this this GitHub action that started. So I can go into the details section and I can watch this happen. So this deployment's happening, and we're now in this wait for deployment section. And while that's running, because the orchestrator is going to have to take some time, it's going to have to create me that S3 bucket. What we can do is we can spend a little time to look in the Humanitec dashboard at what this will start to look like. So this deployment is going to be happening in my automated app. And you can see I have two static environments that I have set up. I have development and I have prod. But now what's also being created dynamically on the fly for me is this PR14 environment. And if we go into here, we can see we have one active deployment, because obviously this is completely new, and it's been done through score. So we can watch this happen. We can also look at the details that are inside as well. So we have one workload, which is called Hello World, which, if you remember, was the name of my workload in my score file. And if we go into here, we can start to look at the resource dependencies it has configured. It has a Postgres database, it has DNS, and it has images. So that's all going to be now created dynamically, and my container is going to start up. So I can see this is happening now. I can head back over to my pull request. And now, about a minute later, we can see we have a message which has been automatically created, which is deployment complete for PR14. I have a link to go view this in Humanitec, like I just did. But also, I have a URL for my Hello World workload, which I can click through and test. Now, it's a little quick for Let's Encrypt. That's no problem. And now, in my freshly created domain name for PR14-automated app, I can test out my Hello World workload. And this can be incredibly valuable because now as a developer, I can test this out. I can work through it. I can try and find problems and then just simply go, oh yeah, that's my bad. This was supposed to be hello team after all. I could then commit that, push to my pull request, and that's going to trigger the same actions again to update this environment with the latest changes in about a minute, like we saw. I can keep testing. And I can also share this URL with my team members. So if I've tested something and I want to show it to the product team before I merge it in to make sure it's definitely what they wanted, I can share this URL and it can live for as long as I need, right? And then once this works and we all agree this was the best change anyone's ever made, it's perfect, Will, you're such a great developer, we can go ahead and merge the pull request. Or in this case, I'm going to go ahead and close it. And when we merge or close this pull request, what's going to happen is a very similar flow. It's going to trigger a GitHub action to run, which is going to clean up this environment. And you can see I've got another pipeline running now. And if we come into here, we'll see I'm back down to just development and prod, and this other environment is gone. And that has just completely cleaned up itself. Any of the infrastructure created, so my database, my S3 bucket, my domain name, are all going to be deleted behind the scenes, and it's not going to cost any more money. So this is really valuable for being able to create new things, test things out as a developer, share things, find bugs, get help from my colleagues, and generally move quickly, which into like today's climate is what's most important for developers. You know, you saw here that I wasn't stuck behind, hey, can I open a ticket because I need an S3 bucket to test a new feature? I wasn't stuck behind, you know, oh, someone else is testing something in development, please don't break it. I was able to just work quickly, you know, on myself or as part of my team, and then collaborate. So with all that, I'm ready to answer some questions if we have them.
Alrighty, thank you.
No worries.
I really like your presentation, and we already have a couple of questions. So the first one, how do you deal with when your workload has other workloads as dependencies? In that case, I would have to deploy them one by one.
No, that's not the case. So when I have a deployment like this, I have an app which only has one workload in. But when you have an app, you can think of it as a product sometimes that have multiple workloads inside that app. I think I can actually show an example of that. So I have my bank demo app here, which has 3 completely separate workloads inside it. So, for example, my front end app, which is running here, has dependencies on the 2 other apps that exist. And if we went in to look at the score files for these, I don't quite have them ready. You can see it's possible to declare dependencies on other services in the score file. So it would be handled like that. And inside the orchestrator, when I do a deployment on something like this, the deployment for all of these is treated as one transaction. So if I needed to deploy, I can go ahead and do it. If I wanted to create a new environment of type development called Will's test, not twest, test, I can go ahead and create that new environment. And you can see it's going to bring all 3 workloads of it with me that are part of that. So this is one way of doing it. If you wanted to have shared services that other workloads depend on, you could do that as well. But because these environments are so easy to make with the dynamic configuration management, this is probably the best way of doing it. I hope that answers your question.
Yes, and if you have any following questions, Diego, please feel free to put them in the chat. But well, we have many questions to answer, so get ready. Can you please show some of the mappings between resources defined in this core YAML and pre-configured infrastructure components like the database buckets?
Sure. So let's go back. I'm going to go slightly off piece for this. So what I'm going to do is I'm going to create a completely new application, which is called demo in this case. And we can spend a little bit of time looking how infrastructure in a score file, which is really abstract, turns into real infrastructure, like a real database or a real S3 bucket. So to do that, we're going to head over to the score getting started project. So inside here, I have a score file, very similar to the one you just seen. And I can go ahead and I'm going to deploy it just from my terminal this time without the GitHub action. So in here, I'm saying I need DNS and I need MySQL. And you know what? Let's add a S3 bucket as well, just for good measure. Yeah, nice, quick. Perfect. So I'm now going to have 2 deployments that are running. And if we go into this one, this is the application I just made right now from that score file. We're going to see that it's using a database, it's going to be using DNS, it's going to be using an S3 bucket. So what's going to be used to create this S3 bucket is resource definitions that I've set up in advance. So mine are a little messy compared to what an actual customer or user of Humanitec would look like, because I use every cloud and test every different thing. But I can tell you what's going to be used is this resource definition called Terraform S3. And if we go into the usage section, you can actually see that. You see my demo app here for images is being used. And it's being used because I deployed to development. Remember when we talked a little bit about context over here? This is what we mean. So we're talking about matching criteria. And as a platform engineer, I have configured this to say, hey, if someone in their score file says they want an S3 bucket and they are deploying to either development or staging, I want you to run this Terraform. We're going to look a bit more about that later, but this is how that flow is made. And I can have these golden paths, which is basically what this resource definition is, for all the common pieces of infrastructure I knew my developers need. And one thing that's really good to be aware of is you'll notice that when I'm requesting infrastructure here, I'm requesting raw things an application can depend on. You know, I'm not saying I need a VPC, for example, because that's way too much details and cognitive load that a developer shouldn't have to worry about. What we're talking about here is the raw things my application needs. You know, I've written code for MySQL, I've written code for S3 buckets. And that's what I create resource definitions for. So I create golden paths for. So I'm able to define resource definitions for basically anything. In this example here, obviously I'm running Terraform. In your question, you mentioned pre-existing static resources. So that's something we can absolutely do as well. So if we go to create a new resource definition, we can start to look at what a resource definition actually is. And they're made out of 3 parts mainly. So the first thing is the type. And this is something a developer is going to request. So let's say if it's a MySQL database that a developer has requested. So we have lots of different drivers that are available. And a driver is the implementation, is how should this thing be made? And that might be to use one of Humanitec's built-in drivers, or you might have custom drivers like Terraform you want to run. But we also have the static driver. And this is one of many ways, probably the simplest, to add existing infrastructure. So let's say I already have a MySQL database that my DBA team manages, which is shared between every application in development, right? What I could do is I could call this the dev-db. My name is dev-db again, sure. I'm going to connect as user. My password is going to be password123. I'm going to set the host to whatever the host name might be. And Humanitec is automatically going to treat these details as secrets where it makes sense, like the password and the username. So I'm going to click add. So now I have a static resource, an already existing database, which I can go ahead and see. So now we get on to sort of the third point, which is matching criteria. So matching criteria what tell the orchestrator when should you use this thing, because someone putting MySQL in their score file doesn't mean you should always use this one database, because I might have different databases for different environments. So a really common thing to do is to create environment type level rules. So I might say, this is what you should use whenever you deploy to development. This is the database you should use. But I can get more precise than that. I can start to say, hey, when you deploy to development and your application is the demo application, you should use this database. And that allows me to be really precise in how I hand out infrastructure. So I could create a resource definition for everyone in development gets this, or every ephemeral environment gets this. Or, hey, I'm migrating this particular application into Humanitec, and I want to bring its pre-existing database along with it. So I could, set up rules for that exact thing. That was a really long answer, but I hope it was useful.
Thank you, Will. Next question. Let me take from the chat, because I think Leah did that question a little bit earlier. The environment is spun up directly by Humanitec, and there is no other AIC config on the backend aside from the score file. Do the developers generally have access to Humanitec, or is that only the platform engineers?
So I hope I answered part one of that question, which is Humanitec is making the environment. There's no other IAC. There might very well be, because Humanitec is going to make this using resource definitions you have set up. So for example, my S3 bucket that I created is made via Terraform, because I have custom Terraform to make that bucket. So how things are made individually, it's completely up to your platform engineering team. You could use our drivers, you could write your own Terraform, you can actually make your own driver, which is totally not in scope for this webinar, but a really interesting topic. So how it's made is completely up to you. Talking about the sort of second part to your question of, do developers generally have access to Humanitec? And that comes down to you. So we have a robust RBAC system built into the platform. And some teams, their developers want to write Terraform, and the developers want to be knowing all the details about how things set up. So sure, let your developers create resource definitions so they're not duplicating work. But then we also have lots of people who use Humanitec who are, for example, banks, and they have very different opinions about whether developers should be able to run whatever Terraform they like, right? So how you implement this is very much up to you. So you could, when you add users to Humanitec, give them permissions. For example, hey, you can deploy to this development environment, but no further. Or you can only view deployments, and all deployments must be done by pipelines. As you saw, I did a deployment completely from my terminal. That works for me, but I'm a complete administrator in my demo org. But that might be something that you definitely don't want people doing. So really long-winded answer. We generally see that developers are allowed to deploy things into dev, but not into other environments. But every customer is completely different, because they have different compliance rules and different just culture internally. We'll work with you is the short answer.
That's true. Thanks a lot for your presentation. I'm not saying by here. This is from one of the attendee. But these additional environments are costly. How can we detect what services must be rebuilt in a PR and deployed?
Mm-hmm. So when you think about when you create this new environment, everything needs to be made available. So the orchestrator is going to try and create everything for this environment. But what I showed with like the static driver is you can not create new infrastructure in every deployment. So if your application is generally, hey, I want to deploy to Kubernetes, I need a Postgres database. What we see a lot of people do is allow developers in their score file to say, I need Postgres. Very simple. But create a resource definition so that in development and ephemeral environments, you just share one instance, which is very cheap. So you have one database, and Humanitec can create new databases in that instance using the Postgres driver. And then when you create a new environment in Humanitec, it's going to deploy the pods into Kubernetes, create a new database in an existing instance for no additional cost, and then wire that up. And then when you deploy that same environment, so same app to production using the exact same score file, it's going to use the resource definitions again with the context of, hey, this is production now. And it's going to do something completely different, like create the big Postgres instance with 10 nodes across multiple AZs that you need for production. I hope that answers the question. Short answer, you can reuse existing infrastructure and share it between environments, but that doesn't have to like add a load onto the developers. They can just think it's new.
Cool. How does the resource resolution work on the backend? Is it possible to configure the infrastructure components in a graph? For instance, if your database resource has a dependency on a secrets resource.
So I think I answered some of that, but it's very interesting you use the word graph, because the way this is done is with something we call the resource graph. And basically, you're absolutely correct. When you have resources like databases and S3 buckets, they often require other things to be able to give the developers what they need. The simple example is, for example, S3 buckets. So when you create an S3 bucket, that's all good, but how is the application going to speak to the S3 bucket? It needs credentials. So when your developer says, I need an S3 bucket in my score file, you need to have a resource definition to create the S3 bucket. But then it also makes sense to have a resource definition which the S3 bucket depends on for creating an IAM role or an IAM policy, to set up the authentication for that bucket. Another really common case would be if you have a really rigid separation between applications, you might have resource definitions, which is, I want to deploy an app and I want it to have a database. But that database might need a whole new VPC. It might need lots of other deeper things like in the infrastructure, which can be configured see, also makes sense. Yeah, can be configured as resource definitions, but abstracted away from developers. Because the last thing we want is developers to be thinking, oh yeah, what VPC do I need for my database? That's terrible. All right, hope that helps.
Next question. Do changes need to be committed to the branch to be picked up? Any way to push code changes to the environment more directly?
I did that earlier in my demo by doing a deployment straight from my terminal. Perhaps I didn't make it very clear though, because I was kind of being quick. So for this score getting started app that I created the demo earlier, I have this deploy.sh file. And basically we're using this score Humanitec CLI app.
You're not sharing your screen, are you?
Oh yeah, I'm not sharing my screen. I stopped sharing my screen. Yeah, so I have this deploy.sh file, which sits along with my score file. And I simply just ran this deployment locally. And this is the same command that my GitHub Actions are using to do the deployment. There's absolutely no dependency on Git. It's just a common workflow that people use. So I demonstrated it today. I hope that helps.
I think next question you answered it like 2 times already. Can I add my own resource definitions, right? You can.
Oh yeah, yeah.
And then if I need the outputs of Terraform to send the information to the application, the properties in the score files needs to match the Terraform outputs.
Yes. So in my score file here, better example, because I'm not actually using these. Hang on, I did it here. In this score file, we listed the bucket and the region for what we want to be able to access. And then we're able to set up variables for them here. So these variables are actually coming from outputs. So this is the Terraform that I'm using to create the S3 bucket. And as you see at the bottom, these are outputs that I have configured. So these variables could be absolutely anything. Humanitec doesn't force you to create any particular infrastructure when you use something like the Terraform driver. So I happen to just be using like the standard S3 bucket module and then passing variables I want to use back. So you were absolutely correct.
And I guess one last question. Is Humanitec commonly used to manage Kubernetes resources like services and ingress controllers?
Yes. So in the demo that we did, that was actually all done for me. I guess I'll use my demo app here. So when I did this deployment, it created a new namespace for my app. I have a Kubernetes ingress object. In this case, I'm using the default service account, but anything like labels, annotations, readiness probes, all that good stuff is available to be created here. So this is something where we start to think about how we want to offload and abstract things from developers and where we want to cut lines. So what I've decided to do in my setup is to do everything via services. If you define a service, you get an ingress with it, because that just makes sense to me, because you need that ingress. You can be way more precise in how you set this up. And also, sometimes it makes sense to have these things be standards rather than things developers individually control. A really common use case for that would be things like labels. So I might have a policy in my organization, which is every application must have a Kubernetes label for the cost center, for example, so I can track that in my FinOps sessions. So I have a resource definition here, which is set to development, and it's for Kubernetes labels. And obviously, Kubernetes labels aren't something that my developers are requesting in their score file. It's actually an implicit resource definition that's always used if available. And what we do in the setup here is we're adding a label with the environment ID in this case. So when I do a deployment, I automatically add a label called env_name with the ID of the environment. And then that, I don't have to ask my developers, hey, make sure you add in labels to your score files across my 1,000 apps and getting really messed up. This is something I could just enforce as a standard, and it just gets done automatically. And you can do that with basically any part of the Kubernetes spec. So get back to your question.
Magic happens.
Yeah, do the wave hands, but just
hi, Davo. Davo was a speaker at our webinar last week, but I guess since we have a couple minutes more, one last question. Are you able to automatically turn resources off when they are not in use? For example, the Postgres database you referenced, when the developer or certain action is not using it, are the resources turned down?
So this is something you could absolutely set up. So in Humanitec, welcome to this demo app that I so handily made. What you can do, and this is all possible via the API as well, I'm just going to do it in the UI, is you can pause environments. So what this will do is it'll spin down pods. And for things like ephemeral environments, because you can make one in a minute, just delete it when you're not using it, right? So you can have all sorts of automation in place to say, hey, this pull request has been open for a week. I'm going to delete the environment. and here's a button to click if you need it back. This is all sorts of things you can do, because creating new environments, deleting them is so easy. You don't have to, you can kind of change the mindset of how you think about them. If you're not using it, delete it, blow it away, because creating a new one only takes a minute. And also you can pause things in Humanitec manually if you want to.
Nice. I guess that will be the wrap. Thank you so much, Will, for your time. I love to see this trend that the shorter presentation you make, the more questions you get. So that's very cool to see how engaged everyone is. Guys, one more time, if you're not part of the platform engineering Slack channel, join in. It's a cool community to be in. Next week we will have another webinar on building multi-region resilient applications, emphasizing chaos engineering with lead software engineer from Capital One. So might be interesting segue into next topics, chaos engineering and stuff like it. We'll send over slides. We'll also mention the repo, right, that is accessible for everyone. We'll attach it in the follow-up email as well as the webinar replay. So you can start using it. Also, should we include the link to the free trial, or I guess people can find it themselves? Yes. So thank you, everyone. I hope you have an amazing end of the day, and see you next week.